Okay, so today we're going to finish up section 4 of the prerequisite chapter, and today we're going to factor completely. So basically all we're doing is just going to combine all the factoring types that we covered in P4A, B, and C. So you may need to factor more than once. Your first step should always be to look for a greatest common factor. After that, you may end up with, maybe there's only 2 terms, and then you're going to look to see, is it the difference of 2 perfect squares? Is it the sum or the difference of 2 perfect cubes? If there's 4 terms left behind, then you could factor by grouping. Or if there's 3 terms, it could potentially be a perfect square trinomial, or you may have to use the traditional factoring. Now, on the perfect square trinomials, you can also still resort to the traditional factoring that we covered yesterday. It's just going to be probably larger numbers. Like, so for example, let's say your perfect square trinomial had 49 and 144 at the ends. If you do the traditional factoring and have to multiply 49 times 144, you're going to get a huge number that you're going to have to find factors of. But if you would have recognized that that first number was a perfect square and the last, try square rooting it and doubling it. And if it gives you the middle, then you can just do the perfect square trinomial trick. Okay, so here are examples. So they want us to factor completely. And this is going to be the instructions that you're going to see on the quiz next week. It's not going to say, hey, this is a perfect square trinomial. Or, hey, factor this difference of 2 squares. The instructions are just going to say, factor completely. So always look for a greatest common factor first. So my greatest common factor between 12 and 48 is going to be 12. So I'm going to divide both of my terms by 12. I'm going to write down the GCF. And then in the parentheses, I'm going to put what remains after I divide. So 12x squared divided by 12 is going to just be x squared. And 48 divided by 12 is 4. Notice what remains in the parentheses is the difference of 2 perfect squares. So I can keep going. So I write down the GCF. And then now to factor the difference of 2 squares, all I do is square root each term here. One's going to have a plus sign. One's going to have a minus. So when you factor the difference of 2 squares, one's a sum, one's a difference. Do not forget about that original GCF that you divided by. So for number 2, we're going to look for a greatest common factor between x to the third and 16x. Notice the GCF of the numbers is a 1, but they do have a variable in common. They both have an x. So I'm going to divide each term by the GCF, which is x, write down that GCF, and then what remains, again, another difference of 2 perfect squares. And again, you're going to square root the x squared, square root the 16, create your 2 binomials. One will give a plus sign, one's a minus. Remember, when you do this, you can multiply these 3 terms back. If it doesn't go back to the original, you've done something wrong. For number 3, we need to make that x squared term, that 9x squared, positive. So I need to factor out a -1 GCF first. So I'm going to divide everything by -1 because that's the only GCF I can divide. And then after I divide it, all of the signs are turning opposite. Now it's a 3-term polynomial or trinomial. First thing I'm going to do when I have a trinomial is I'm going to look at the first and the last term. If I can recognize that these are perfect squares, I'm going to test to see, is it a perfect square trinomial? If not, then I have to resort to the traditional factoring where I multiply first and last. So here I'm just going to square root the 9x squared. I get 3x. Square root the 1. I get 1. And then double it. And it did give me the middle. So now I can do the shortcut. I'm going to just write down my GCF. The square root of 9x squared is the 3x. The square root of 1 is 1. And then I take the sign of the middle term from the original that after I divided the GCF. So the sign is a subtraction, and then it's the binomial squared. Do not forget about that negative sign out front of that binomial. For the next one, number 4, put it in standard form first, then look for a GCF. So for number 4, I'm going to put it in standard form. I'm going to put the largest exponent first. So the negative 3x to the third plus 9x squared plus 12x. And now I'm going to look for a GCF. So my GCF here is going to be negative 3. So I'm going to divide, actually negative 3x. They all have an x in common. So I'm going to divide each term. So now I'm going to divide negative 3x. When I divide negative 3x cubed by negative 3x, I'm left with x squared. Positive 9x squared divided by negative 3x is going to give me negative 3x. And then positive 12x divided by negative 3x is negative 4. Now at first glance, you may say, oh, that looks like a perfect square trinomial. So let's try it. Let's test it out. So if I square root the x to the x squared and square root the 4, I get x times 4. And then if I double it, or sorry, x times 2. And then if I double it, I get 4x, which isn't my middle. So now I got to do the traditional factoring. So what I'm looking for are two numbers that multiply to give me negative 4, but who will add to give me the middle term, negative 3. So once I figure out my factors of 4, it's either going to be positive 1 times negative 4 or positive 2 times negative 2, but the one that works is going to be positive 1 times negative 4. So then I can put those right into my binomial because the coefficient in front of that x squared is a 1. So x plus 1, x minus 4. And you're done. The order of the binomials doesn't matter. You could have written the x minus 4 first. On number 5, notice that this is the difference of two perfect squares. So all I need to do is square root this first term, square root this term, and then they're going to go right into my binomials. So the square root, when I square root this x squared plus 8, that's just canceling this. So out of this is going to become x squared plus 8, and I write it in both spots. Then the square root of 36x squared is going to be 6x. One's a plus sign, one's a minus. I now need to write my trinomials in standard form to see if I can keep factoring. So once I take this one, put it in standard form, and this one, I can now use my traditional factoring technique and factor this. So what I'm looking for on the left one is I'm looking for two numbers that will multiply to give me 8, but who will add to give me the middle, which is 6. And those two numbers are going to be positive 2 and positive 4. So this will factor into x plus 2, x plus 4. For the second trinomial, this one, I'm looking for two numbers to multiply to give me positive 8, but who will add to give me the middle, which is negative 6. Those two factors of positive 8 are going to be negative 2 and negative 4. Because when I add negative 2 plus negative 4, I get negative 6. So this will factor into x minus 2 and x minus 4. And I'm done. And again, remember, if you want to multiply these 4 binomials back together, it should go back to the original. All right, for number 6, I'm going to factor by grouping. So I'm going to make a group here in green, and then I'll make a yellow group. So I'm going to look for the greatest common factor of my green group, and that's going to be x squared. So I'm going to divide each term by x squared. And then now I'm left with 3x plus 1, because x squared divided by x squared is 1. And then for my yellow group, if I pull out a GCF of 9, I won't get the match. So I'm going to pull out a negative 9 GCF. After I divide, 3x plus 1. Notice these are the same. So I write that down once, and then take the two GCFs, and they become the other binomial. So then I'll put these two together. But notice in the second binomial, difference of two squares. We can keep going. So this one, factor into x plus 3, x minus 3, and then this one just comes straight down. And now we're done. So for number 7, this is one term here, and this is your second term. Now, if it makes it easier for you to see the GCF a little bit better, you could split this binomial that's squared and show what a binomial squared means. It means to write 2x minus 1 twice. Let me just rewrite the first one. So now you can see what the part that they have in common, the GCF, it's the binomial. It's the 2x minus 1. So we're dividing by that GCF. So I write the GCF down. I'm going to write what remains after I divide. So this is going to cancel. This is going to cancel. So now from the first term, I'm just left with the 4x. And from the second term, the 2x minus 1. I have like terms here that I can combine. So my GCF, rewrite it, and then combine the like terms. And I'm done. And that's it for the factor completely examples.